Let's take a look at the graph of tangent x. Just like with sine and cosine x, I'll make a table of values, we'll plot the points and see what we get. Okay, let's remember something first. Tangent x is the exact same thing as sine x divided by cosine x. So let's keep that in mind as we're graphing this function. So let's get a table of values. We'll plot some points and see what we get. All right, let's figure out what the tangent of 0 is. Well, tangent of 0, that's the same thing as sine of 0, which is 0, over cosine of 0, which is 1, which is 0. So there's 1 point on the tangent function. How about if I choose pi over 4? Tangent of pi over 4, remember, there's pi fourths. Tangent of pi fourths is opposite over adjacent, so tangent of pi fourths is 1. How if I do negative pi fourths? This angle down here. The tangent of negative pi fourths is opposite over adjacent, so that's negative 1 over 1. Okay. Now how about we try pi halves? Well, tangent of pi halves, that's the same thing as sine of pi halves, which is 1, over cosine of pi halves, which is 0, and we're in trouble. Can't ever have division by 0, so the tangent of pi halves is undefined. Okay. Also, tangent of negative pi halves is also undefined. So let's see what we get. Let's plot these points. 0, 0, pi fourths 1, negative pi fourths, negative 1, and we'll keep this in mind that those two values are undefined. All right, so here's 0, 0 right here, the origin. Maybe I'll put 1 here. Remember, pi fourths, so if this is pi half, so pi fourths is somewhere in here. Tangent of pi fourths is 1. Tangent of negative pi fourths is negative 1. Okay? And remember what we got at pi halves, it was undefined. So what we actually have here, I'm going to put a little dotted line here. That's called an asymptote. And that's what we get. Tangent of 0 is 0. Tangent of pi fourths is 1. As we get closer and closer to pi halves, this curve gets closer and closer to this asymptote, and the same thing over here. Now, what's interesting is I can put some more values in. What's going to happen at pi? Well, if I plug pi in, tangent of pi is sine of pi over cosine pi. Sine of pi is 0. Cosine pi is negative 1, which is 0. So there's another point, pi comma 0, which is right here. And actually, this thing is going to repeat itself again. We're going to have an asymptote over here at 3 pi halves. Okay. We can guess what's going to be over here. Another asymptote over here. And it's going to look something like this. Okay? It will repeat itself forever and ever and ever. This is the graph of the tangent function. Now let's try to figure out what the domain is. Notice I can plug any number into the tangent except these guys. So we have to figure out a way to describe the domain. The domain is going to be all reals except for these points right here. Except for pi halves, 3 pi halves, 5 pi halves, etc. negative pi halves, negative 3 pi halves, negative 5 pi halves, negative 7 pi halves, etc. So the domain is going to be all x values except odd increments of pi halves. And this is how we describe that. The domain is the set of all x values. This little line means such that. So the set of all x values such that x does not equal k pi over 2, where k is an odd number, okay, an odd integer, such as 1, 3, 5, 7, etc. So the domain is all x except for odd pi over 2's. Okay. The range, well, that's nice. The range is all real numbers. This arrow goes up forever. This arrow goes down here forever. So the range is negative infinity to infinity. The only thing we have to remember is that the domain is a little bit restricted. Pretty easy to think of. Since tangent is equal to sine over cosine, wherever the cosine is equal to 0 is where the tangent is going to be undefined. And cosine is equal to 0 at pi halves, negative pi halves, 3 pi halves, 5 pi halves, etc. All right, let's look at a little better looking graph of tangent x. Again, this was off of a graphing utility. I went ahead and graphed it for you. Now, when you have a graphing calculator and you want to graph something like this, just to check, if you have asymptotes, usually they give you a solid line for the asymptotes. You can say here's the x-axis, here's the y-axis. And these lines are the asymptotes. They don't actually appear when you graph it. These are actually imaginary lines. So notice where they are: pi halves, 3 pi halves, negative pi halves, negative 3 pi halves, etc. Okay? So these are the graphs that you have to memorize. You have to be able to graph sine x. You have to be able to graph cosine x. You must be able to graph tangent x. Okay? So practice graphing these things until you have them memorized.